Welcome everyone. In this video I am going to talk about the very famous Clairaut's equation. This is the last video in the series of differential equation of first order and higher degree. So let's start. In case if you are new to the channel and have come across the channel for the first time, you should subscribe it, because here you get good quality video content, right? And I already have uploaded 3 videos in this series, solvable for p, solvable for y, solvable for x. So in case if you want to have a look at them also, you can check. So first of all, what is Clairaut's equation? So Clairaut's equation is a very standard form of the equation. It looks like y is equal to px plus a function of p, right? For example, suppose I write some examples, like I write y is equal to px plus under root 1 plus p square. If I write another example, y is equal to px plus 1 plus p square square. If I write y is equal to px plus log of p. So all these are examples of Clairaut's equation. I hope you are very much clear that here by p what I mean is dy by dx. Okay, so here p stands for dy by dx. So all these equations, all these 3 equations or examples that I have taken are the form of Clairaut's equation. So Clairaut's equation, suppose it is given and we are asked to solve the Clairaut's equation. So it has a very quick solution. What we do, that to solve the Clairaut's equation 1, so I write it to solve equation 1, or to solve means when I'm talking about solving the equation means I'm talking about general solution. So to solve the equation 1, we just write the solution in one step. What we do, we replace p by c and we get the solution. So for example, if I have to write the solution for this, I will get the solution y is equal to cx plus under root 1 plus c square. If I have to solve this, I will get the solution as y is equal to cx plus 1 plus c square square. If I have to solve this, I will get y is equal to cx plus log c. So we don't have to do anything, we can directly replace p by c to get the solution. But some of you might be thinking that why it is so, right? Because engineering student or science students are usually curious about this. So I'm going to explain that as well, and I will also talk about the singular solution in particular. So now let us talk about this situation, that suppose we have y is equal to px plus fp, and we suppose don't know that we can get the general solution by replacing p by c. So what I will do, if you look at this equation, it looks like that it is solved for y, because we have y in one side and all the terms of p and x on the other side. So it is basically an equation which has been solved for y. So when you know that if you have an equation which is solved for y, how do you find the solution of it? You differentiate it with respect to x. So that is what I am doing. I am differentiating it with respect to x. So I will get dy by dx, and here I will get p and plus x dp by dx, and the function of p, if I differentiate it with respect to p, I will get f dash p dp by dx, right? Now you might be aware that in this process we replace dy by dx by p. So I have p is equal to p plus, and here from the last 2 terms I can take dp by dx common, so I get dp by dx. So what we got after this, we got x plus f dash p dp by dx is equal to 0, and this is a very important kind of, let me call this equation number 1, let me call this equation number 2. Now those who have watched the previous video, they might be aware that we solve it when we come across this situation, we take this as a part of singular solution, and to get the general solution we focus on that part which contains dp by dx. So suppose I am trying to solve it for the general solution, what I do, I will take dp by dx is equal to 0, and I will ignore this part. So if dp by dx is equal to 0, of course if you solve it, you will get p is equal to c. Yes or no? Because dp will be equal to 0, integrating both sides will give you p is equal to c, right? So now to get the general solution, if you remember what is the process, you take this equation, original equation, and you take this solution and you call it 3, and from 1 and 3 you eliminate p. So if you take equation 1 and you take equation 3 and if you eliminate p, what will be the general solution? So the general solution will be, the general solution is y is equal to cx plus fc. So this is what I have told you in the beginning itself, that you don't have to do all this step. You can directly replace p by c if you come across any differential equation which appears in the Clairaut's form. Now my intention here is to also talk about the singular solution. So how do I get the singular solution? I take this equation y is equal to px plus fp, and we take this x plus f dash p is equal to 0, and from both this we eliminate p to get the singular solution. So this is the process. So to explain it, I am going to take 2 examples, or maybe more example, but first let us take the first one. So suppose I take an example like p is equal to sine of y minus xp, and the question is that find both the general and singular solution. First of all, I hope you are clear about the general and singular solution difference. In general solution, we have same number of arbitrary constant in the solution, which is equal to the order of the differential equation. So this is a very important remark I am making, that the number of arbitrary constant in the general solution of any differential equation of order n will be n. Here we are talking about differential equation of order 1 and higher degree, so there will be always just one arbitrary constant in the general solution, but in singular solution there is no arbitrary constant, right? So it will be clear from this example. So suppose we have this differential equation and I want to solve it. So in the first appearance it does not look like that it is in the Clairaut's form, but if you just try to rewrite it, you will get y minus xp is equal to sine inverse p, which in turn can be written as y is equal to px plus sine inverse p. Yes or no? Now I hope you will agree that it resembles to the standard form, that is y is equal to px plus fp, because we have px here and we have a function of p here. So to solve it, if I have to find the general solution, I already know that the general solution is y is equal to cx plus sine inverse c, but I am interested in also finding the singular solution. So what I am going to do, I am going to differentiate it and I am going to follow the usual process. So let me call this equation number 1. I have to differentiate in both sides with respect to x. So dy by dx is equal to, if I differentiate this, p plus x dp by dx, and plus derivative of sine inverse p is 1 by under root 1 minus p square. Now what is dy by dx? dy by dx is equal to p, so I get p is equal to p plus, and here I missed one thing, it is dp by dx also, because I am differentiating it with respect to x. So sine inverse p will give me 1 by under root 1 minus p square, and then p with respect to x, and here I get x plus 1 by under root 1 minus p square dp by dx. So now it is like x plus 1 by under root 1 minus p square dp by dx is equal to 0. So it gives me two things, x plus 1 by under root 1 minus p square is equal to 0. Let me call this equation number 2, and it also gives me dp by dx is equal to 0. Let me call this equation number 3. So from this I get p is equal to c, and let me call this equation number 4. So from 1 and 4 I can write, from 1 and 4 we get the general solution, because I can eliminate p here. So I will get what? I will get y is equal to cx plus sine inverse c. But for our convenience I am writing the equation number 1 here, y is equal to px plus sine inverse p. This is my equation number 1, and this part that I have got, x plus under root 1 minus p square is equal to 0, and this was my equation number 2. So if I want to get the singular solution, what I have to do, I have to eliminate p from equation number 1 and equation number 2. So how to eliminate p? So to eliminate p, what I do, I take 1 by under root 1 minus p square is equal to minus x. So this will give me 1 by 1 minus p square is equal to x square. This will give me 1 by x square is equal to 1 minus p square. This will give me p square is equal to 1 minus 1 by x square, and this will give me p is equal to a square root of 1 minus 1 by x square. Right. Now in the equation 1, in place of p I replace this, so I get what? I get x, and here we have 1 minus 1 by x square and plus sine inverse and under root 1 minus 1 by x square. So did you notice this? This is known as singular solution. Why it is known as singular solution? Let me write it. Singular solution. That in this, you look at this solution, it does not contain any arbitrary constant. If you look at this solution, you have the arbitrary constant c in the solution, but in the singular solution you don't have any arbitrary constant. So that is the difference here, that singular solutions do not have much geometrical importance. So that is why, unless stated otherwise, we don't solve it for the singular solution. So if they are asking to solve a differential equation, most of the time we just solve it to find the general solution. But in particular, if they have asked to solve it for singular solution, then only we solve it for singular solution. Okay. So let us take one more example. So here we have another differential equation, that is p is equal to log px minus y. Here also, if you just look at it, it does not look like that it is in Clairaut's form, but we can just do one manipulation. You write px minus y is equal to e to the power p, and from this you can write y is equal to px minus e to the power p. I am interested in finding both the general solution and singular solution. So general solution we already know. If I can write it for you, the general solution we already know, but I want to solve it separately. So we know it is cx minus e to the power c, but I am going to follow the regular process of solving it so that we get the singular solution as well. So what is the process? You differentiate both sides with respect to x. So you get dy by dx is equal to p plus x dp by dx and minus e to the power p dp by dx. Now you know that this is p, so now I am going to cancel both this term directly here, and here I am going to write x minus e to the power p dp by dx is equal to 0. So from this I get x minus e to the power p is equal to 0, and I am going to call this equation number 2, and I am going to get dp by dx is equal to 0. I am going to call this equation number 3. So if I solve this, I get p is equal to c, and I call it equation number 4. So from 1 and 4, so from 1 and 4 we have the general solution. What is we have? We have y is equal to cx minus e to the power c, because I have eliminated p from this. But I want to get the singular solution as well. So let me write the equation number 1. Equation number 1 is y is equal to px minus e to the power p. This is my equation number 1, and I also have got x minus e to the power p is equal to 0. So x minus e to the power p is equal to 0. This is our equation number 2, and from both this I want to eliminate p. So from this equation, what I can write? I can write x is equal to e to the power p, and if I take log in both sides, I will get log x is equal to p. So now from 1, what I get? From 1, in place of p I put log x, so I will get y is equal to x log x minus e to the power p, that is equal to x. So what I have got here is the singular solution, because in this solution there is no arbitrary constant. So this is my singular solution. Okay. So I hope now you are clear about what is the Clairaut's form and how to solve it. in particular, if they ask this kind of question in MCQ and they are asking that solve this equation, and if they have not specified about the singular solution, we will directly replace P by C whenever the equation appears in the form of y is equal to px plus fp. So that's all in this video. In this video I talked about Clairaut's equation. This was the fourth video in the series of differential equation of first order and higher degree. I have put them in the exact differential equation playlist, so you can watch them from there, and in case of any doubt you can let me know in the comment section. Share this video with all your friends, subscribe the channel, like the video. Great watching it. Thanks. Have a great day.